Inshallah, we are going to continue solving of differential equations by using Laplace transformation. In the last part, we have done two questions. Now let we do two more questions in this part. Let we revise. Laplace of y dash is s into Laplace of y minus y naught. Laplace of y double dash is s square into Laplace of y minus s into y naught minus y dash naught. Laplace of y cube is y triple dash is s cube Laplace of y minus s square y naught minus s into y dash naught minus y double dash naught and let me do this question solve using what does it means y equals to 1 dy by dt equals to 2 d square y by dt square equals to 2 at t equals to 0. That is, I'll explain you. Given y of 0 equals to 1 at t equals to 0 means y of 0 equals to 1, y dash, this is y dash of 0 equals to 2, this is y double dash of 0 equals to 2. Now given equation is y triple dash, this is y triple dash plus 2 into y double dash minus y dash minus 2y equals to 0 equals to 0. Now let we do one thing. Let we apply Laplace to the equation. Applying Laplace to every term, so we get Laplace of y triple dash plus 2 into y Laplace of y double dash minus Laplace of y dash minus 2y 2 into Laplace of y equals to 0. What we did, we applied Laplace to the equation. So now let me solve this one. Laplace of y triple dash, just now we have seen its formula is s cube into Laplace of y minus s square into y naught minus s into y dash naught minus y double dash naught. This is plus 2 into Laplace of y double dash is s square into y naught Laplace of y minus s into y naught minus y dash naught bracket minus Laplace of y is s into Laplace of y dash is s into Laplace of y minus y naught minus 2 into Laplace of y equals to 0. Now let me substitute the values of y naught, y dash naught, y double dash naught. You see here, I am writing this as it is. You see here, s cube into Laplace of y minus s square into y naught. Value of 1 naught is 1. 1 into s square is, this is s square. Y dash naught is 2 minus 2s minus y double dash naught is 2 plus 2 into s square plus 2s square Laplace of y. You see, y naught is 1. 1 into s is s. S into minus 2 is minus 2s. Y dash naught is 2. Y dash naught is 2. Just wait. Ys, yeah, this is minus y dash naught is 0. So minus plus into minus minus 2 twos are 4. This is 2. This is 2. 2 twos are 4. Minus into plus minus s into Laplace of y. S into Laplace of y. Minus into s plus y naught. Value of y naught is 1. So this will be plus 1 plus 1. Till now here we got no minus 2 into Laplace of y minus 2 into Laplace of y equals to 0. 2 into Laplace of y. Let me revise once more. Any mistakes here? See here, Laplace y naught is 1 into s square minus 2s minus 2 2s square Laplace of y plus into minus minus 2s into y naught is 1 y dash naught is 2 minus into plus minus 4 minus s into Laplace of y minus 1s plus 1 minus 2. Let me take Laplace of y common. If we take Laplace of y common, here it is left with s cube and here it is left with 2s square and this is finished and this is minus 2. Let me revise once more. See here, if we take Laplace of y common, it is left with s square s, sorry, here we left with s minus 2. Once more revise, s cube, if you take Laplace of y common, s cube plus 2s square minus s minus 2. Now remaining terms, watch here, let me take on the other side. We are having minus s square, bring to the other side, it will be plus s square. Next term is, you see, watch carefully, minus 2s is minus 4s. So bring the minus 4s on the other side, it will be plus 4s. Now lastly, numbers you see here, minus 2, minus 4 is minus 6, minus 6 plus 1 is minus 5. So minus 5 on the other side, it will be plus 5. Now Laplace of y equals to s square plus 4s plus 5 divided by, you get this here, s cube plus 2s square minus s minus 2. You see here, now you watch carefully, this is cubic equation. If you can factorize this, okay, you factorize, otherwise I will show you. We can use the calculus to solve this. This is cubic equation, you say take mode. After mode, you number 5 equations, you go into 5 equations. Then this is cubic equation, the fourth number is cubic equation, so I am taking the fourth cubic equation. This is fx 991 as plus I am using. So in cubic equation, you, what are the coefficients here? S coefficient, s cube coefficient is 1 equals to s square is 2 equals to s coefficient is minus 1 equals to, and s coefficient minus 1, then minus 2. So we'll get the values of the s. See, we are getting s equals to 1, then s equals to minus 1, then s equals to minus 2. So what are the factors? You bring this 1 on the other side, that is s minus 1, minus 1 on the other side, s plus 1, minus 2 on the other side, s plus 2. So these are the factors. So you bring this y on the other side, L on the other side, it will be L inverse. So we will get the value of y. So y equals to L inverse of, we write this as it is s square plus 4s plus 5. Now these are the factors of this. What are the factors? S minus 1, s plus 1, s plus 2. Let me note this as equation 1. Now we have already done 2 questions on this. These are the factors in the denominators. To separate this, we will use partial fractions. So let me use the partial fractions and separate this. Okay, after that you will get the formulas. Now let me use the partial fraction for this a, for this b, for this c. Let a by s minus 1 plus b by s plus 1 plus c by s plus 2. So let me take the LCM. You write this as it is s square plus 4s plus 5 divided by s minus 1, s plus 1, s plus 2. You take the LCM, s minus 1, s plus 1, s plus 2. Now you bring this to here, a into what will be the value? This will be s plus 1, s plus 2 plus b into, you leave this s plus 1, s minus 1, s plus 2. Now plus c into, leave this one, s minus 1, s plus 1. Now this will get cancelled. What is left here? Let me write once more. S square plus 4s plus 5 equals to a into s plus 1 into s plus 2 plus b into s minus 1 into s plus 2 plus c into s minus 1, s plus 1. Now let me solve this one. You see here, let me make one after one zeros. See here, now let me start. Suppose if you put s equals to 1, 1 minus 1 0, this whole term will become 0, 0 into a number 0. 1 s is 1 minus 1 0, this whole will become 0. See, if you put s equals to 1, this 2 will become 0, you'll get the value of a. So put s equals to 1. So 1 square is 1, 1 plus 4 is 5, 5 plus 5 is 10 equals to a into 1 plus 1 2, 1 plus 2 3. 1 plus 1 2, 1 plus 2 3. 3 to the 6, bring this 6 here. So a equals to 10 by 6, 2 5 are 2 3. So now we got the value of a. In the same way, let me make a 0, another numbers. Now watch carefully, what should we keep to make this 0? S plus 1 make 0. What should we keep? We must keep s equals to minus 1. Minus 1 plus 1 is 0. So next step, put s equals to minus 1. Minus 1 plus 1 becomes 0. Minus 1 plus 1 becomes 0. We'll get the value of p. So if you keep minus 1 here, minus 1 square 1. 1 plus 5 6. 6 minus 4 2. Minus 1 square plus 1. 1 plus 5 6. Plus 2 minus 1. 6 minus 1. 6 minus 4 is 2. So plus 1 minus 1, this will be 0. This will be 0. You get come here. B into minus 1 minus 1 minus 2. 2 minus 1 is 1. So 2 ones are 2 is the b minus here. So you get the value of b as minus 1. B as minus 1. Now lastly, put s equals to make this 0. What should we keep? keep in the place of s minus 2. So put s equals to minus 2. Minus 2 square 4. 4 plus 5 9. 9 minus 4 to 8. 9 minus 8 is 1. Minus 2 square 4. 4 plus 5 9. 9 plus into 1 is minus 2. 9 minus 8. Sorry, 2 8 is 4 is 8. 9 minus 8 is 1. So this is 0. This is 0. Minus 2 plus 2 0. You come here. Minus 2 minus 1 will be minus 3. Minus 2 minus 1 minus 3 plus minus 2 plus 1 will be minus 1. Minus into minus plus, bring this 3 here, c equals to 1 by 3. So we'll get Laplace inverse of, see here. Now we have to keep in place of a value, in place of b value, in place of c value. So what is the value of a here? 5 by 3. Write this outside. 5 by 3, 1 divided by s minus 1 plus b. The b value is minus 1, so minus Laplace inverse of 1 by s plus 1 plus c is 1 by 3, Laplace inverse of 1 by s plus 2. Now let me use the formulas. 5 by 3 into Laplace inverse of 1 by s minus a is e power at. Minus 1 up, we get plus 1. 1 into t is 2. As Laplace inverse of 1 by s plus a is e power minus at. If plus, you have to write minus. If minus, you have to write plus. 1 by 3 e power plus 2, no, we have to write minus 2. So this is the solution. Now see here, the same question, sometimes in place of x, y, dy by dt, sometimes it is given in dx by dt in terms of x. So we have to use this formula as x dash. Same, in place of y, you keep x, s into Laplace of x minus x naught, s square into Laplace of x plus s into x naught minus x dash naught. Similarly for q. So if the question is given in terms of x, we have to use these formulas. So let me first write the what is the given here. X double dash plus 2x dash plus 5x equals to e power minus t sine t. What is given already? This is given x dash of 0 equals to 0, x dash of 0 equals to 1. So let me apply Laplace to each and every term. So Laplace of x double dash plus 2 into Laplace of x dash plus 5 into Laplace of x equals to Laplace of e power minus t sine t. Now how do you solve this one? This is first shifting. Whenever you get e, that is first shifting. So leaves e, first you find the Laplace of sine at. Sine at is a by a is 1 here by s square plus a square is 1. Now when we apply e with it, multiply e with it, s will become s minus a. S will become s minus a. So minus a is minus 1, so minus 1 is plus will come. This s will become s minus a when we multiply with e power at, this first principle. So s will become s minus a. A is minus 1 is plus 1 whole square plus 1. So let me solve this one. 1 divided by a plus b whole square is a square plus 2b. 2 ones are 2s plus 1 square 1 1 plus 1 2. So see here. Now let we use the formulas. Laplace of this one is s square into Laplace of s minus s into x naught minus x dash naught. This finish plus 2 into this is s into Laplace of x minus x naught. This one plus 5 into Laplace of x equals to this value we already find here. This is sorry s square plus 2s plus 2. Now see here, let me do one thing. No, s naught is x naught is 0, so this is 0, leave this one. Okay, let me do Laplace of x, Laplace of x, Laplace of x. I am taking Laplace of x common. So what is left here? S square. Then Laplace of x, if you take common, 2 into s will become 2s plus 2s. If you take Laplace of s common, x common, this will be left with 5. This is finished. X naught is 0, so 0 into a number 0, leave this one. X naught is minus, this is 1, minus 1. Minus 1, if you bring on the other side, it will plus 1. This is also 0. So this will be 1 by s square plus 2s plus 2. Minus 1 on the other side, it will be plus 1. So watch carefully. We are multiplying here this on. If you bring on the other side, it will be divided. So divide both, or else you do one thing. If you take LCM, this will be multiplied with 1. So 1 plus s square plus 2s plus 2 by s square plus 2s plus 2. I'll explain this one more. Let me take LCM here. If you take LCM, this will be multiplied with 1. So 1 into s square plus 2s. So this will be s square plus 2s plus 2 plus 1, 3. Now if you bring this, it will be in the denominator. I will write this one. Therefore, Laplace of x equals to s square plus 2s plus 2 plus 1, 3 divided by, this will come here. So we'll get two terms here, s square plus 2s plus 5 into s square plus 2s plus 2. Now we have to partial fractionalize, we have to partial use partial fractions to separate this. We have to use partial fractions to separate this. I do one thing, you see here, if we use the direct method, it will be so lengthy because this is a quadratic as plus b, then this as plus d will be lengthier. Let I am doing one thing, let for some time, this is, you see, same here also, here also, here also. So let me put s square plus 2s equals to, for some time let me keep this k or whatever you suppose some constant. So if you bring L here, Lap already you got no. So this is actually Laplace inverse of x equals to Laplace inverse of. So if we change what is left here, Laplace inverse of this we suppose as k. So this will be k plus 3 divided by, this will be k plus 2, k plus 5, k plus 2. This we for some time you suppose this as k because this is common, so it will become easier. This will be k plus 2 and this will be k plus 5, k plus 2, whatever. Okay, so let me change, let me partial fraction this one. After that we will change the question. Okay, now let me solve, let it suppose for this a, for this b. So we will get this as a by k plus 2 plus b by k plus 5. So let me take LCM here. You write this as it is, k plus 3 by k plus 2 into k plus 5 equals to, if you take LCM, you get k plus 2, k plus 5. So here you will get ka into k plus 5 plus b into k plus 2. So this will get cancelled. So what is left here? K plus 3 equals to a into k plus 5 plus b into k plus 2. Let's suppose put k equals to minus 2. Why? This minus 2 plus 2 will become 0. 3 minus 2 will become 1 equals to 5 minus 2 is 3, 3a. Therefore, a equals to 1 by 3. See here, if you put k equals to minus 2 plus 2 will become 0. So 3 minus 2 will become 1, 5 minus 2 will become 3. Similarly, you keep k equals to minus 5. Minus 5 plus 5, 0. Minus 5 plus 3, minus 2. Minus 5 plus 2, minus 3k. Minus 3b. So minus minus cancel. So b equals to 2 by 3. Therefore, this will become Laplace inverse of a. The value of a is 1 by 3 by 1 by k plus 2 plus b is 2 by 3. Laplace inverse of, Laplace inverse of what we are having, 1 by k plus y. Now again you keep the value of k here. So this will become, just now we suppose k as 1 by, k value is s square plus 2s. So this will be s square plus 2s plus 2 plus 2 by 3 into Laplace inverse of 1 by s square plus 2s plus 5. So let me change now. These two terms we have to factorize. We have to make perfect squares. We have already done how to make the perfect square. Let me change here. See here. First one is s square plus 2s plus 2. S square plus, you change this into 2. This is already 2. So right, 2 into 1 into s. This is b. So we have to add b square, subtract b square, again plus 2. So till here you will get the formula, a square plus 2a plus b square is a plus b whole square. 2 minus 1 is 1. We already done this in the previous classes. See here, this also, s square plus 2s plus 5 equals to s square plus 2 into 1 into s. 2 can be written as 2 into 1. This is a square plus 2a, this is b. So we have to add b square minus b square plus this 5. Now a square plus 2a plus b square is a plus b whole square plus 5 minus 1 will be 4. So we can change this one. Let me change this one. So what is left here? This can be written as 1 by 3 into Laplace inverse of 1 divided by s plus 1 whole square plus 1 plus 2 by 3 into Laplace inverse of 1 by s plus 1 whole square plus 4 can be written as 2 square. Now see here, let me continue. Few steps are there. So watch carefully. Now whenever we get like this s plus 1 like this, we must use s plus 1 or s plus 2 first shifting. When we use first shifting, watch carefully, Laplace inverse of, when we use first shifting, this s plus 1 will become s. This is first shifting. S plus 1 become s. With that we will get e power at. We have to change the sign. Plus 1, no, we have to take minus 1t means minus t. Write 1 by 3 as it is. In the same way, plus 2 by 3 into Laplace inverse of, watch carefully. This, when we use first shifting, this s plus 1 will become s. S plus 1 will become s. But we have to multiply with e power at. Plus 1, no, minus 1t. Now next step is, this is directly cos 80, sorry, this is sin 80. 1a by s square plus a square is sin 80. This is also sin 80, but sine formula is a by s square plus a square. A by s square plus a square. We want a here. A means here is 2. So to get 2 here, you multiply by 2 and divide by 2. So this 2 will get cancelled. 1 by 3, 1 by 3, let me take common. 1 by 3 e power minus t from both. So this is a by s square plus a square is sin 80, sin 1t means sin t, plus we have taken this common, a by s square plus a square is sin 80. So this will become sin 2t. So these are few questions we have solved on based on differential equations. So inshallah that we continue in the next class. So I request you all to like, share and subscribe my channel. Inshallah we are going to continue in the next class.